Hey guys, Easy Science again. Back again with videos. Sorry for the long break between videos. I was busy with school and stuff. Now I'm back. I'll be making videos every week. Trust me. Alright guys, let's get into the video. So today's topic will be acids and bases. Two very interesting subjects that are related. So you guys have heard of acids maybe in your house, like vinegar or something. And maybe you've even heard of bases, of like soap and stuff, cleaning detergent. But what are they really, right? That's the big question here. Well, today I'll explain. Okay, so right now I'll explain to you I won't explain exactly what acids are and bases yet, because I want you guys to have an idea of what they can be in your household. So, as you can see in this image right here I made it a bit bigger. So, these are examples of acids and bases. As you can tell, the higher you go on scale, the more basic the element gets, or not the element, the thing you're testing, and the lower on the scale, the more acidic. So what is this scale? pH scale is a universal indicator scale. So it basically tells you how strong an acid or base is, depending on the numbers that are. If it's lower, like I said, more acidic, the higher, more basic. So some things to know: water is always a 7 on the pH scale. 7 means neutral, as you can tell, 14 and 0. If we find the average, 14 plus 0 divided by 2, 7. So in the middle directly is water. Seawater is an 8. It's an 8 because it has salt in it and other minerals, which make it more basic. Those are light examples. Another light example of acid is black coffee. You may feel an acidic taste when you drink it. That's why it's a bit more acidic. Now let's go to the extreme side of things. The most acidic thing, like I was going to say, is battery acid, or something in there. Why? Because batteries need very powerful acids to work. In this case, they use sulfuric acid. You might have heard it with horror stories, or like hydrochloric acid. Very strong acid. If you get that on your skin, you're done. Your skin's done. It can go through plastic. It can go through metal sometimes because it eats it away. Here we have on the other scale, some basic things. Very basic things, such as drain cleaner. It must get through all the stuff in your drain that builds up. So bases, you might think, aren't as strong as acids, but they are. Maybe even stronger, as they can also clean things. So a good example of an acid is your stomach acid. Because as you know, acids can break things down. How do you break down food in your stomach that you eat? With acids, right? So let me tell you guys, as a quick review, just so you know what I'm talking about, right? Atoms can have ions. Or it can be ions. So basically, let's take hydrogen. Or let's do a better example. Let's say sodium. So Na, that's pretty bad right here, one sec. Na right here has 11 protons. 11, right? And that means in its normal state, it would have 11 electrons too. But here I'm going to write P plus, I'm going to write E minus. But an ion is when there's a difference in electrons and protons. So when there are more protons than electrons, what does that mean? If protons have a positive charge and electrons have a negative charge, that means it becomes a cation. That means it is positively charged. So in that case, that would be where 11p and 10e. You can't change the proton amount because that would change the element, but you can change the amount of electrons. This can be an example for other things, such as chlorine, where it would be one more, which would make an ion. So that's how it is. Okay, so let's take chlorine for example. You guys probably heard of hydrochloric acid, right? I think everyone has at this point. So what chlorine does. Okay, so let's take chlorine for example, right? Cl, that's its formula, and what's its thing? It has protons, which are 7 of them, and 7 electrons. As we know in the valence shells, so in the last valence shell is the really one that matters, because to be stable, all the valence shells, which are the electron shells, the first one is 2, second one is 8, 8, 16, goes on. Have you heard of noble gases, right? They're so stable because all their valence shells are full. There's no extra space, which means nothing can be made with it. That's how compounds are formed, when the valence shell gives an electron or takes an electron and they share it and then complete their valence shells. So it's like you want to complete something, but you really need something else. And when you complete it, you're like, oh, I don't need it anymore. That's how the atoms think. That's why chlorine is very reactive, because it only needs one more. It will go anywhere to get it. Or something with 3, that they need 3 more electrons to be complete. They're not so reactive because it's hard to get 3 of them. Okay guys, a bit off topic here. So this is my little sister. She wants to say hi to you guys.
Hi guys. My name is Anna and I'm 8 years old. And yeah, so bye.
Yeah, she's really interested in science just like you guys. She just wanted to say hi. If she makes a YouTube channel, link it down in the description below. You guys should check it out.
Don't forget to subscribe to his video and leave a like.
Okay guys, back to topic. So, like in our example here, chlorine is very reactive because it only has 1 electron it needs to complete its shell. Since in the first shell there are 8, it has 7. It needs 1 more to become an ion. So we could count it as an ion with, so let's say it gets another electron. So then it would be how many more? It'll have a -1 charge. So there's 1 more, so it'll be negative because electrons have a negative charge, so 0 minus 1. That's for the ion. And let's say hydrogen, because hydrogen is basically found anywhere, and water and stuff. There are free like ions of hydrogen. So hydrogen ion would be H, and since it has P1 and E1, to make it an ion, this has to be here. I'll just put 8. This would have to be 0 to lose its 1 electron. So it would have no valence shells, which would mean it's pretty stable. So then it would be plus, because there are more. See, look, there are more here. In this case, it would be P is less than E. Here, P is more than E. So then there would be more of a charge, which would make it positive. What happens with positive and negative charges? They attract. So in this case, if there are free ions of chlorine and hydrogen, they would connect with each other. And this would create HCl. And in the acidic case, you have to put aqueous. So AQ, indicating that it's an acid. So right here, what has been happening? It has, since the hydrogen has nothing, and it needs someone to connect with, it just connected with the chlorine since it needs that extra hydrogen. This makes it the 1, so it makes it an acid. And why are acids so reactive? So basically that hydrogen, since if it's an ion, it wouldn't really need it. That's why they're so reactive. Let's say we have this chair. Let me give you an analogy right here. Let's say you're sitting on the chair, right? The chair and you, since you're sitting on each other, you're bonded. Let's say you're an ionic bond between 2 atoms. And when hydrochloric acid comes in, it sees you, and basically, let's say it launches the proton at you. So it takes it. So because hydrogen 1 is basically a proton, it launches at you. It's like, take it, take it, take it. And since you don't want it, but then the chair might have to take it, and when it takes it, it's like you're adding a super big weight. Let's say that hydrogen, there's a guy sitting on the chair, and you're the hydrochloric acid. You come up to him and throw a 50-pound plate on him. It's like, take it. He takes it, but then you'll probably collapse with the chair and get hurt. That's how molecules act with an acid. The acid throws the hydrogen, they take it, but then the bond breaks, which basically dissolves the object. That's why they get dissolved, because it breaks all the bonds. An important thing to know also is in water, with the donated hydrogen, it would create the ion H3O plus hydronium, which is an important thing about the acid. In this case also, it takes them. So let's talk about bases now. Let's give you a base. So sodium hydroxide, let's think of it right now. Sodium hydroxide is a pretty powerful base. And let's say NaOH. So that's a pretty powerful base. What it does, a big characteristic of a base is in water it releases the OH minus. So release an OH minus, right? Instead of protons, it's basically releasing something that has less electrons and needs them. That's why it's connected with the sodium. So basically, it donates also as well, but this time it can take them. Since OH is not an extra thing, and since it's a negative thing, it needs an electron. Because of this, since you know oxygen needs 2 electrons, and hydrogen has 1, it's still in the minus section. So hence it has a minus, it needs 1. It needs 1. Nitrogen just chilling there, so that's good. So in this case, it takes them. Or it gives away protons. Not protons, electrons. It takes protons from them. So why is that's in a sense more powerful? Since taking something is easier than giving something and waiting them for accept, right? Like with that analogy, a base would just take the chair handle or something, so then the whole atom breaks, molecule breaks. So that's why it's easier. So in general, bases and acids are both pretty powerful things, but it's very important to know when there's a base or acid. So that's why there are things that assist you in this. A good way people indicate and get when there's an acid or base are indicators. As you see on this chart, you can use litmus paper. So when you dip this into your substance, such as hydrochloric acid, I wouldn't recommend that. But let's say vinegar. And when you dip it in, it will turn red to indicate it's an acid. For if you drop it into some drain cleaner ammonia, it will become blue in the base section. There's also liquid indicators such as phenolphthalein, which as you see on this chart, when it's put into a thing where pH 0 to 3, pretty strong acid, it becomes orange. pH 4 to 7 is colorless. pH 8 to 10 is pink, and the other is colorless. I would say this happens because it doesn't change the object itself or the liquid. It just because of the acidity, it may take away a proton or add a proton, which would change the color slightly. So this isn't the most effective thing unless you combine some. I would say litmus papers, and there's some litmus paper that you might know that's yellow, such as something like this, which basically indicates everything on the scale, which is very easy to use. So in this case, if you know you're working with an acid, you must be careful, wear enough safety protection, and as well check the acidity, know what you're working with, and in general, if you're curious to find out, go into your house or something, find some acids, bases, test them, write in this description below what you found interesting about the bases, acids, what their pHs are, because some of them might differ a lot, right? Okay guys, thank you for watching this video. Really appreciate it. I know I haven't been making videos in a while, but I will make videos now more often because school, new semester started, so now I have science and I'll be very interested to make that. These are some cool things I found just playing around a bit. So if you like the video, subscribe, leave a like, leave comments for extra videos. Watch out for next week for my new video. Alright, Easy Science out.